There's no physical barrier to biological immortality and rejuvenation. We already know that biological immortality is possible on the level of cells. You can take a aged human cell and you can reset the biological age of those cells to a day zero embryonic stem cell. So you can wipe away most of the epigenetic marks of aging in those cells. And so that's a proof of principle that we can reset the biological age of cells, and humans are just agglomerations of cells. So therefore, we should, in principle, be able to do that in the whole body. I would say by the end of this century, we will have multiplied human lifespan, if not achieve biological immortality.
Hello and welcome to Polyweb. I'm your host, Sara Tortoli, and my guest today is Sebastian Brunemeier, a molecular neuroscientist and general partner at Healthspan Capital, a venture fund focused on longevity biotech and regenerative medicine. In this very wide-ranging conversation with Sebastian, we cover how we can potentially reverse aging and live a much longer and healthier lifespan. What is the latest status of the scientific research, and how do you redesign society for a population that doesn't age? There are only two certainties in life. One is that you have to pay taxes, and the other one is that you're going to age and die.
Yeah, Ben Franklin, the US president, Ben Franklin, was famous for there are only two certainties in life: death and taxes. And so, one of them is certainly not a complete certainty.
Well, I mean, growing up, I found out that if you live in the right country, you don't necessarily have to pay taxes. It's just a matter of which country do you live, right?
Exactly. Yeah, it's shades of gray. Yeah, some countries the tax rate is heinous, horrendous, and some it's zero. Dubai is very popular right now for that reason. Agreed.
Yeah. So, and now, you're busting the second myth, which is you don't necessarily have to die. Or is it, right? Does aging equal dying? Granted that, of course you can be killed, right? If you are in a car accident, you can die, right? Of course. But does not aging means not dying? And maybe we can get also into the definition of what is aging. What's the process that's happening inside the body?
Sure. Yeah, happy to. So there's a difference between health span and lifespan. So most people will agree that it is desirable to extend the healthy period of life as long as possible. This is the objective of medicine, the field of medicine writ large. It's to reduce the suffering from disease and extend healthy lifespan. That is related to the idea of biological immortality. So there are those among us who are biological immortalists, and they actually believe, as I do, that it would be massively beneficial if humans lived longer, ideally forever. And so we can get into that. There isn't any very strong evidence that humans can be immortal anytime soon, but there are many lines of evidence suggesting that we can dramatically extend our period of good health. So the longest lived human on record was somewhere around 120. And, you're in better health for most of your life as one of these long-lived supercentenarians, but you still age and decay quite similar to the rest of us. But there are new technologies such as Yamanaka reprogramming that have gotten a lot of attention recently, basically where you can take a aged human cell, like say a skin cell sample, you put it in a petri dish, you treat it with three or four different genes. These are called Yamanaka factors. There was a Nobel Prize awarded some years ago for this discovery, and you can reset the biological age of those cells to a day zero embryonic stem cell. So you can wipe away most of the epigenetic marks of aging in those cells. And so that's a proof of principle that we can reset the biological age of cells, and humans are just agglomerations of cells. So therefore, we should, in principle, be able to do that in the whole body. The current barrier to that is the engineering challenge of delivering those Yamanaka factor genes to enough cells in the human body in order to make a difference. So that's a gene therapy delivery problem presently. There are some other problems too. But anyway, so that's one proof of principle. But we've known for centuries, if not millennia, that you can slow the pace of aging. Fasting and caloric restriction is the best studied way to do that. So if you cut the caloric intake of mice by about 1/3, they live about a third longer. They age at a slower pace. They're a little bit irritable. When this was done in the primate studies at the National Institute on Aging, it was remarkable how much younger the fasted animals looked. The fasted monkeys looked, and they were running around far more youthful. Their cognitive function was preserved. They were younger in every way that you looked, but they were hangry. They were irritable. So that's one of the downsides of caloric restriction, and chronic lifelong caloric restriction will reduce in most species. I don't know about humans, but in most species will reduce fertility and so on. So it's not very practical to do that level of caloric restriction. You may get similar benefits with intermittent fasting, ketogenic diet, low insulin signaling type diets, but the jury is still out. But it's certainly good for your health and preventing many age-related diseases. And then you have other gene and cell therapies that I think are going to make a huge impact in the coming years. There's going to be a revolution in medicine with these new, what we call modalities, gene and cell therapy. So for the last century, couple of centuries, we mostly used small molecule drugs. So like pills that would come, molecules, chemicals that would come from plants or microbes. And that was the basis of most pharmaceuticals. And then really starting in around the 1950s, the synthetic chemistry revolution took off. And so we have all these non-naturally occurring medicines too. But these small molecules, these pills, they're not very powerful. They only kind of tweak the system a little bit. But these gene and cell therapies enable us to reprogram biology and rebuild tissues and organs in a way that we've never been able to do before. And so I'm very excited to see the first few dozen gene and cell therapies in the clinic now, and some approvals already by FDA and EMA.
Wow. But what happens to the body, when we age? How is that possible that we can take those cells and turn the clock back? And if this is proven true, right? How often can we do it? Like, is it indefinitely? Can we reset the clock indefinitely? And as
Yeah,
you mentioned, potentially live, forever unless you're killed. Or like vampire, they chop off your head and they put a stake in your heart.
yeah, for sure. Or like the Wolverine thing,
Yeah.
like incredible regenerative capacity. Yeah, the jury is still out. It's early days. Right now, we don't have anything that can achieve quite that level, but there's no biological reason why it wouldn't be possible. It's not that there's entropy or that the programmed aging is insurmountable. So, with enough capital, talent, scientific prowess in the field, there's no physical barrier to biological immortality and rejuvenation. So, we'll give you another example. We already know that biological immortality is possible on the level of cells. It has been that way for billions of years since life emerged on this planet, because there's an unbroken chain of continuity in descent in your lineage from you to your parents and their parents and their parents and their parents. So this is called germline immortality. The germline, or the germ cells, described by August Weismann, this evolutionary biologist, developmental biologist in the 19th century, described how you have two major cell types in the body, two categories of cells. You have the soma, which is all of your body that walks around doing things. And then you have the germ cells, which are the reproductive cells in the gametes, in the reproductive tissues. And those germline cells, they are potentially immortal. So when you conceive a child, the sperm and egg meet, and that resets the biological age of the embryo at that point. And then some of the cells in that embryo, so that embryo will divide, it will get to, say, 100 cell stage, 200 cells, and some of those cells will be sequestered. They will be held in reserve to remain reproductive cells. And the rest of those cells, most of those cells will become the soma, which are your muscles and your organs and your brain and all of that. That's the soma. And the soma is sometimes thought as a glorified meat suit. It's just a vehicle, it's just a vessel that transports around your reproductive cells for the purpose of, propagating your genes in the Richard Dawkins selfish gene sort of theory. Not that genes make you selfish, but that evolution and everything that we do falls within this framework of certain genes being like memes that want to self-propagate into the future. And that's the be all and end all of life, is just the continued propagation of these genes. And it's just a coincidental happenstance, chain reaction. And that's what life is, according to Dawkins and others. So anyway, so the germline is immortal. That is has been known for a very long time. That's another proof of physical immortality on the cellular level. So it's not like entropy is insurmountable or anything. So I'm very optimistic on the long-term timescale, the half-century, century timescale. I would say by the end of this century, if things continue at the pace that they are, or ideally faster, we will have multiplied human lifespan, if not achieved biological immortality. I think in the next century, we will have either solved that problem or realized that it is unsolvable for some reason that is unknowable today, or that at least I'm not aware of. So I'm quite optimistic. What everybody listening should do, if you care about the long bio field, if you care about living longer and better health and treating the root causes of disease, which is aging itself rather than just the symptoms of disease, the many heads of the mythological hydra, you should tell everyone you can about the longevity field. You should invest in the space. If you have friends in biotech, you should tell them to do that instead of whatever they're doing, and just raise awareness for this field, because it really is like, it's got to be like a missionary zeal, like proselytizing on some religious sort of movement, in order to get as many people involved and aware as possible, because ultimately we're fighting for our own lives, right? It's like, if we don't succeed in this, it's so far 100% guarantee, 100% failure rate of the biological system. We all will succumb to disease and death from aging if we don't die from something else. So I can't really think of something more useful to do than to try to extend your healthy lifespan and ideally achieve biological immortality.
Speaking of, what's the latest status of the research right now? And how soon do you think we could start experimenting on humans?
Yeah, there are some humans who are taking matters into their own hands. So there are people like Brian Johnson, who I really like, who got a lot of press attention recently for spending a couple $1 million on his very high end concierge longevity medical program. So he has pretty impressive discipline, or rather, he's structured his life in such a way that it doesn't require willpower or discipline in order to make all the healthiest choices. So he goes to bed early, he's optimized his sleep, he does intermittent fasting, caloric restriction, he takes a zillion supplements. He, has this team of doctors and medical professionals. He's doing the highest end diagnostics and whole body MRI and all of this. And he's open sourced it. So he's put it on his website, Blueprint, Brian Johnson Blueprint. And you can check it out and implement some of it for yourself. And the fundamentals of it are not expensive. I mean, it was estimated he spent $2 million on it, but the basics are pretty straightforward. And he basically says the main thing we need to do is stop being self-destructive, stop all of these self-destructive habits, whether it's, like workaholism and stress, to eating foods we know are bad for us, or staying up late, and all of that, or not exercising, so that's obvious. But let's assume that you're living the perfectly ascetic diet and lifestyle already. What do you do then? Well, there are some supplements you should check out that do seem to slow aging in mice. And there are some pharmaceuticals that seem to slow aging in mice too. People know about metformin. Metformin does a little bit, but it's maybe a little overrated and not good for you if you're in good metabolic health to begin with. It's good for you if you're overweight or insulin resistant. Another one is rapamycin. This is my personal favorite. This has been known for quite a long time to extend healthy lifespan in mice up to about 20%. Rapamycin has an interesting story. It's actually an FDA-approved drug for suppressing immune rejection of transplanted organs. And so it turns out at a low dose, it actually induces autophagy, inhibits translation, enhances proteostasis, reduces inflammation, has a lot of other interesting properties. And so, some of the world leaders in the field of rapamycin biology, studying its gene target called mTOR, some of the world leaders are taking it. So a friend of mine, Matt Caberlin, who's on the advisory board of Healthspan Capital, he's probably one of the top 3 world experts in rapamycin, the molecular biology, etc. And he's personally taking it. And people like Peter Attia, if you're familiar with him, he's a famous longevity celebrity now. So he's taking it, at least intermittently. So rapamycin is a good one. You want to take a relatively low dose and optimize it with your doctor. Not medical advice here, but you can do some research into that. But these are only kind of tweaking the metabolic pathways a little bit. What we really need are these incredible step changes in the engineering. And that will come with when we rewrite the code of biology, namely gene therapy, as well as embryo selection. It's too late for us, but children, people coming in the future, we can do embryo selection where we fertilize a bunch of embryos by IVF. Then we do a genome sequence on some of the cells of that embryo. And we can predict all kinds of properties about that baby: health risk, longevity, IQ, and intelligence. All kinds of properties we can predict with increasing predictive value, with increasing accuracy. So that's rewriting the code of life. George Church talks about that a fair amount as well. That is hamstrung and held back by the gene therapy delivery problem that we're all relying on these viral vectors to deliver genes to cells. But we're working on that. But the other one that I'm really excited about and that I'm personally dedicating much of my time to is cell therapy. So your listeners may have heard about various cell therapies, some revolutionary therapies in the cancer space. So one is called CAR T cell therapy. So one of your immune cells that is an effector type cell that actually kills infected cells. It is called a T cell. And this T cell is normally, when we're young and our immune system is functioning properly, it's constantly surveilling for nascent tumors. So you and I and everybody listening, we're always getting cancers. Every day, we're getting new would-be cancer cells. But our immune system surveils for and ablates these nascent tumors. And that's one reason why cancer is an age-related disease, because of immune senescence. Our immune system loses the ability to target cancer cells as well as pathogens, infectious agents like coronavirus, for example. The leading risk factor for death from coronavirus, believe it or not, was not your political party or orientation toward the vaccine. It was actually your biological age. And so young people were at almost zero risk from COVID, we now know, but older people were at significantly higher risk. And so what if that didn't have to happen? What if we did not need it was not required that our immune system would fail with age? And this is an area that I think is really underappreciated. So I spent about 10 years in the longevity field and on the venture capital side, as well as biotech founder side, as well as in the academic side. And I came across very few companies that were seeking to rejuvenate the immune system. And so it was similar story with the first company that I founded, Samsara Therapeutics in Oxford, England, working on autophagy enhancement. So I'll just back up and give you the brief story there. One of the reasons why fasting is good for you, fasting and exercise respectively, is because they turn on this cellular process called autophagy. So autophagy comes from the Greek self-eating. When you do fasting, the cells break down their internal components, their organelles, and then rebuild them. It's a recycling process. And when you genetically enhance autophagy in mice, they live about 15% longer. Their muscles work better. Their brains work better. They're younger in most ways that you look. And so what if we had a pill that would induce autophagy without the difficulty of fasting? And so in the academic literature some years ago, there was strong evidence that there were small molecule drugs that could induce autophagy. The jury was in on that. And yet there were almost no biotech startup companies seeking to find new autophagy enhancing small molecules. And so I launched this company in Oxford, England on autophagy enhancement. And since then, a handful of other autophagy companies have been launched. One was even acquired by Big Pharma, Merck, et cetera. And so now it's become hot. And so it's a similar story with the third company that I've launched now. The one intermediary company is Cambrian Biopharma, which is a large multi-asset company working on many hallmarks or aspects of aging. But the most recent one is ImmuneAGE Bio, where we're targeting the immune system. So we're trying to rejuvenate the hematopoietic stem cells and other immune cell types like T cells. And so it's known that if you take young bone marrow from young mice and transplant it into an old mouse, that old mouse will live about 30% longer, and it looks younger in every way that you check, improve cognitive function, cancer surveillance, pathogen resistance, improve cognitive function, less dementia, etc. So the challenge is you can't really do that unless you have managed to bank your own cord blood as a baby, your umbilical cord blood. Most people haven't, but if you're going to have kids, you should definitely bank their cord blood. So what's the next best thing? The next best option is you rejuvenate the hematopoietic stem cells, the bone marrow stem cells that you already have. So again, the HSCs, they give rise to all of the immune cell types in the body. T cells, B cells, red blood cells, platelets, all of it comes from this one cell type, this highly proliferative hematopoietic stem cell. And so what we do at ImmuneAGE is we are able to mobilize these HSCs from your bone marrow into your peripheral bloodstream, which has been routinely done for decades in the bone marrow transplant space. We put them in a petri dish. We can expand their numbers. We can cause them to grow by about 1,000 fold, which is the world record. Prior efforts were about 10 to 20 fold. We can get 1,000 fold, 2 orders of magnitude greater than before. And 2 Nature papers came out of this work from our collaborators at Oxford, Stanford, and elsewhere. And with that large supply of HSCs, aged human HSCs, we can, for the first time, do large scale, high throughput drug screening to find cocktails of molecules that rejuvenate the HSCs outside of the body or ex vivo. And then we reinfuse those HSCs back into the bloodstream. The amazing thing about HSCs, one of many amazing things about them, is they know where to go. They know to home back to the bone marrow in circulation. And so, and this is, again, a variant of this has been routinely done for nearly a century now in the bone marrow transplant space. But we are, to our knowledge, the first to apply it to age-related diseases rather than, say, leukemia and diseases for which bone marrow transplant is routinely done. And we can do it without the necessary ablation or elimination of the existing bone marrow, which is done with chemotherapy and radiation today. So that would not be necessary with our approach. And so we're very optimistic about the ability to rejuvenate the immune system to treat many and prevent many different diseases, from cancer, infection. Cardiovascular disease is highly driven by chronic inflammation and immune dysfunction, as well as neurodegeneration, you name it. So it's pretty clear to us that aging of the immune system is one of the primary drivers of organismal systemic aging. So that's what I'm focusing on right now.
Wow. I'm getting super excited about this. By the way, is the pill that stimulates autophagy available? Because I was really looking into it, but to, from what I know, to stimulate autophagy, you need to fast for like two minimum 3 days, and I really didn't wanna. I really don't want to do that because I don't want to lose weight. I'm a lightweight already. I don't feel like that fasting 3 days would be the best for me. So that's I was
Yeah.
really interested.
Yeah, sure. So a couple points there. Fasting, there's no reason to believe that there's a specific cutoff point, a specific number of days that you need to fast in order to induce autophagy, because autophagy is always occurring. So there's always a basal level of autophagy in all of our cells. It's just a matter of gradation, a matter of intensity. And so it's true that you may hit a plateau after X number of days, But even if you just do intermittent fasting, or you just do caloric restriction, or you do a ketogenic diet, anything that lowers your insulin level will increase autophagic flux, all else being equal. It is not known, and I worked with some of the world leaders in the autophagy space, like Guido Kromer. Uh, it's not yet known what is the optimal dosage of fasting for autophagy induction or any kind of health benefit. There are a lot of clinics all over the world that'll do medically supervised fasting. I think that's very cool. I think that's probably one of the first things I would do if I had a serious disease, or even just for maintenance. But you can just increase your autophagic flux, for example, by doing fasted exercise. So if you get up in the morning and you haven't eaten anything and you exercise, then you're going to increase your autophagy under those conditions too. So it's not necessary that you have to do a really heroic long-term fast to benefit from autophagy.
Okay, that's a relief. I'm curious to know what you do personally for longevity. Do you follow a particular regime diet, which supplements you take, keeping in mind that none of this is medical advice, and everyone should talk with their own doctor because everybody is different.
Totally. I'm of the opinion that the paleo diet is the correct diet for most of humanity. Bread and carbs are new. Evolutionarily, agriculture's only been around for about 10,000 years, which is the blink of an eye in evolutionary time. We've been Homo sapiens for like 300,000 years, right? As hunter gatherers. So my diet tends to be, I mean, I cheat all the time, but my diet is basically high quality grass fed meat heavy. Organ meats I like as well. I don't particularly like the taste, but there's a lot of bioavailable nutrients in there. I try to minimize processed food and carbs. I try to keep my insulin levels low and steady. I do intermittent fasting. I do regular exercise and yoga every day. And yeah, and I eat a fair amount of fruit too. That's my carbohydrate source. Just from an evolutionary perspective, and you can, for more on this, you can check out the work of, what's his name? Saladino, Paul Saladino, MD, medical doctor, carnivore MD, he's called, and he just eats uh, animal foods, high quality, grass fed, and fruit, basically. And that works for me. And so, in addition to that, I take lots of supplements, cognitive enhancers, and I try to get enough sleep. That's probably my main vice, is that I stay up too late. I don't sleep enough. And yeah, a lot of the sort of more obvious stuff. So yeah, that's basically what I do. For people who are particularly interested, you can reach out to me on LinkedIn. I have a document that I sometimes share with people with the specifics of what I do, what I take, and why, the rationale behind it.
Going back on the state of research, what have you seen so far that you think has the biggest potential or is getting you the most excited these days among, the startup that you're seeing in this field?
So there are areas that have gotten a lot of people excited that I think are maybe at this point slightly overhyped.
Okay,
One I've
like?
already, yeah, one I've already mentioned is epigenetic reprogramming, Yamanaka reprogramming.
Hmm.
So yes, you can reset the epigenetic age of cells, but it's still early. The jury is still out on the exact effect size on healthy lifespan extension with that. And yet, billions of dollars have come into the reprogramming space in recent years. So you have Calico, which is Google's company. It's a 3 plus 6 billion, actually $6 billion entity effort, partnered with the big pharma AbbVie. They're a little bit secretive, Bell Labs sort of approach. You also have recently Altos Labs, which is 3 billion with supposedly 10 billion earmarked from very prominent investors like Jeff Bezos and Yuri Milner and people like that. And they've recruited a lot of top scientists in the longbio field. So there has been a lot of effort recently in the epigenetic reprogramming space, but there are, open questions in that field. And to their credit, Calico and Altos have diversified their research portfolios to many other hallmarks of aging, many other aspects of aging. Areas that I like that I think are underappreciated: DNA repair is a big one. That is one of the four primary hallmarks of aging. So for the scientists among us, there's a good review article. It's the most cited review article in this field, called The Hallmarks of Aging. And it breaks down the biochemistry, of aging into 9 different molecular processes. And it's kind of a derivative inspired by Aubrey de Grey's work earlier, some years earlier, called the 7 Deadly Sins, which breaks down into 7 categories, the molecular basis of aging. And so one of them is DNA repair, another is proteostasis failure, epigenetic drift, stem cell exhaustion, mitochondrial dysfunction, et cetera, et cetera. And so there are all of these lines of evidence that DNA repair is critical for lifespan and healthy lifespan. So if you do a linear regression of lifespan versus DNA repair capacity, most animals, most species will fall on that line. But there are some outliers, and those outliers include humans relative to other primates. We have way better DNA repair capacity than other primates. Supercentenarians, so humans within the species who live very long time in good health, even despite bad diet and lifestyle, we know what some of the genes are that confer that lifespan, that extreme lifespan extension. And some of them are DNA repair factors. We also know that in humans, the accelerated aging diseases, we call these progerias, or like reverse Benjamin Button diseases, they're very sad. Young kids will age very rapidly. They'll die by the time they're teenagers of the same type of stuff that mostly kills the rest of us, like cardiovascular disease and cancer. And though these progerias, there are something like 20 of them known, they're all mutations in DNA repair and metabolic factors. So that's another clue that actually DNA repair is super important. And then going back to the comparative longevity work, there's a great researcher in the field who I did a podcast interview of her recently. Her name's Vera Gorbanova in New York, and she is one of the leaders in the comparative longevity space. So she studies long-lived animals, so like very long-lived whales, like bowhead whales and sperm whales, that kind of thing, as well as this interesting species called the naked mole rat, which is a rat that lives 30 years instead of 3 years. Normal rats live 3, naked mole rats live 30, and she's uncovering with her colleagues some of the mechanisms that confer that extreme longevity. She also studies bats because bats live a lot longer than they should, also around 30 years relative to their size. It's a huge outlier. So anyway, this area of comparative longevity, I think, will yield a lot of non-obvious approaches, drug targets, mechanisms we should pursue. And one of them that's popped out of there is DNA repair fidelity. And the crazy thing is that there are almost 0 companies in the longevity field working on enhancing the fidelity of DNA repair. So that's a soapbox that I often get on top of. Tried to convince the UK government's new fund called ARIA to work on this as well. And we're going to hopefully speak to ARPA-H, the US government's new extreme healthcare organization, to work on this as well. And then beyond that, a specific disease that we need to really work on more is cardiovascular disease. So CVD is the number one killer of all of us. Something like 50% of us or more will die from vascular aging related diseases, whether it's heart attack or stroke or related. And yet pharma spends very little R&D dollars and various government agencies very little money on cardiovascular disease, even though it's the leading cause of death and disability. And they spend so much money on cancer research, oncology field. And oncology is the second leading cause of death. But it's incongruent. It's not in proportion. And so we can get into the politics and logic behind that. But I often tell people who are coming into this field or looking for something to pursue, if you really want to extend healthy human lifespan, you need solutions to vascular aging. And so autophagy enhancement does help with the vasculature. One of the companies we've invested in, Early Repair Bio, is engineering macrophages to clear out the junk that accumulates in the vascular wall. And so very, very keen on getting more people to work on vascular aging. So those are a couple examples of fields to pursue.
So when you do research in the labs related to longevity, what's the sample like? Like, is it mixed men and women? And do you see differences between the two?
Yeah. So historically, there was an overrepresentation of male animals and humans in research. That is changing. And yes, oftentimes with some of these interventions, whether they're pharmacological or genetic or diet and lifestyle based, in the lab, in the mice, we do see pretty significant differences. So there are drugs that extend lifespan in one gender or sex and not the other, or at least less in the other. So for more specific details on that, you can check out the Interventions Testing Program, ITP, which is run by the NIH, National Institute on Health. My colleague Richard Miller runs it, and they do the largest gold standard lifespan studies in the world, like 1,000 mice per condition at 3 different sites. And they actually calculate the percentage lifespan extension of different interventions. And so, yeah, some will preferentially benefit one gender, one sex over the other. And so, would definitely consider that depending on however you identify, as well as whatever your biological sex actually is.
One thing that comes to mind, when you talk about this, is that this is a very technical field, right? Sounds like you need like a PhD, be a researcher in this field to be able to create a company around it, even if there are those huge untapped opportunities, right? So I'm curious, like, what's your take on that? Like, my impression is that uh, people that will want to build a startup that really makes a difference, but they don't have this type of technical background, are kind of cut out.
Yeah. So it definitely helps to have uh, biology background, but it's not necessary. I mean, there are founders in the space who do not have biology formal training, but they're self taught enough to understand the biology and build a team of hardcore subject matter experts. One that comes to mind, company we invested in, is called Oisin Bio, OISIN, and it's led by my good friend Matt Schultz, who is a computer scientist by training, and he is self-taught in biology, and he's really a smart cookie because he understands it as well as anyone. So you don't necessarily need that technical background. Another shout out I'll give, Jonas Sinek, who has a PhD but is in mathematics, and he helped set up BioAge Labs, one of my favorite large longevity companies. And now he's CEO of Equator Therapeutics, a company that we also invested in quite early, and he is self-taught to the extent necessary in the underlying molecular biology. Generally, company CEOs do not need to be, the number one world expert in that area of biology. They rely on their team, their CSO, their hardcore scientific team for that. Um, so if you are a company founder or prospective company founder who maybe you have a tech background, you can link up with hardcore scientists in the field and join forces to raise capital in advance. And you can get in touch with me if you have an interest in raising capital for that. And then furthermore, the easier way to do it is, if you already have technical expertise in a certain field, you're highly specialized there. It doesn't make sense to pivot to something totally new. You can just invest in the long bio field. So one of my friends and partners, Michael Cheenan at Healthspan Capital, it was an AI researcher at Google, very smart cookie, PhD in computer science, and he started investing in this field, realizing that his comparative advantage and most people's comparative advantage will be doing the thing they were trained to do that they're good at. You make money there, and then you funnel it into the longevity field. And we're at such an early stage of the long bio field that relatively small amounts of capital, especially when pooled in a fund, can really move the needle in enabling companies to form that wouldn't otherwise be formed, or to do experiments they wouldn't otherwise be able to afford at the early stage. So investing in the long bio field, I think, is a good way to contribute and get involved.
How specifically, for people that, as you mentioned, don't have this type of background, but still usually believe in this field and want to make a contribution, so what are some concrete ways? You spoke about investing. Okay, where? Where can they put their capital?
Sure. So I used to work at a venture fund, Apollo Health Ventures, and the minimum check size was in the hundreds of thousands or millions. So most people can't afford that. That's one reason why I and my colleagues set up Healthspan Capital, because we can accept small checks, 5K minimum check size, because we ourselves wanted to invest in these companies in a diversified portfolio of long bio companies, but we couldn't afford to write $1 million check into, Cambrian or BioAge or Apollo Ventures, etc. So that's how we got started. And then, a bunch of friends through word of mouth wanted to participate. And now today, Healthspan Capital is the most active investor in the long bio field. We've done 20 deals in our, less than 16 months of operations. And so, that's obviously one way that people can get involved. And then just, spreading the word so that it's just becomes more of like a social meme phenomenon. It's kind of like what happened with AI or with psychedelics. You just needed people to talk about it. There needed to be buzz and this accumulation of interest. And we're starting to see that in the last few years. So I'm hopeful that a lot more capital and talent will come into the field.
Yeah, I mean, we both are as well in the Web3 space. So I think there are like some opportunities there, maybe for people
Mm,
to contribute. And I know that you're a contributor, like at VitaDAO and Molecule. So maybe you can talk about it for listeners.
for sure. Yeah. So mentioned last time VitaDAO. VitaDAO is a very cool organization. So it is a DAO, a decentralized autonomous organization. So these
DAO,
are entities on the blockchain that pool capital to achieve certain ends. It can be investing in longevity biotech companies or financing research in university labs. This is what VitaDAO does. But there are also other DAOs that do wacky stuff. Like there was a DAO that wanted to buy a copy of the US Constitution. They raised like 40 million or something. So there are all kinds of DAOs to achieve any kind of collective good, any collective objective. And so VitaDAO, we've raised on the order of over 10 million within the last 2 years, really kicking off operations in the last year. We've had financing from Balaji Srinivasan, one of my favorite thinkers in this space. He's also an investor in ImmuneAGE, I'm happy to say. He's the author of The Network State, excellent book, and former CTO of Coinbase, etc. So speaking of network states, I mentioned to you before we were at Zuzalu, which is this experimental pop-up city in Montenegro, in the Adriatic Sea, small country, and it was organized by VitaDAO and the Ethereum Foundation, Vitalik Buterin, the inventor of Ethereum. And it was this beautiful, sort of beachside gathering of several hundred people in a series of conferences on AI, synthetic biology, longevity biotech, network states. And so I mentioned network states. I'll just give a teaser because it's not really the topic of the conversation, but there's a really good book by Balaji Srinivasan about the future of governance and this competitive governance field and how we can basically come up with new forms of government where people along certain highly aligned vectors of belief, whether it's longevity or it's keto or it's what did he call it, the digital Sabbath, where like internet is turned off 2 days a week or on the weekend or whatever it is you want to form a community around. You do that. You start on the internet. You find all of the wacky people that are aligned with your view. Maybe it's longevity. And then eventually, when you have critical mass, you start to achieve political ends. So you might finance certain government programs in order to, or advocate for certain changes to policy or governments investing in certain lines of research or whatever. And then eventually, when you get to a certain scale, you can even materialize in a physical place for short periods of time or forever. And so I and my friend Nicholas Anzinger, who runs Infinitive Fund, investing in network state entities who you interviewed, actually, we're looking into various sites, jurisdictions for a longevity network state. And so we're going to be visiting a handful of Latin American countries, the more sort of business friendly ones this winter. So anyway, stay tuned for that. If you're curious, check out Balaji's work, Nicholas Anzinger's work, the charter city movement, the startup city movement, and the network state books.
Yeah, we'll leave the link also to the episode I recorded with Niklas and his podcast, and all the resources that you mentioned for listeners will be linked in the show notes and in the YouTube video description, so they can refer to it. But I would like to switch gear completely. And I mean, by now it's obvious that I'm getting very, very excited about this field, but I want to play the devil advocate for a moment. And I want to play at reversing my personal opinion and talk about the downside instead of a population that potentially does not age and can live, indefinitely. I mean, everyone would like to live healthy and reset their biological age and go on living, right? Maybe not everyone, but a lot of people, I bet. I'm for sure on one of those. But then I can see like potential downsides, right? For every new technology, and also this is a technology, there is the good side, but there is the bad side. So I don't know. Do we really want people like Kim Jong Un, the North Korean dictator, to be able to reset his biological age, right? And rule the country indefinitely? Because so far, I mean, death, it's kind of being the way we free ourselves, and it also has been a way that we gave meaning to life, right?
Yeah. So there are a bunch of philosophical critiques. Let's start with the immortal dictators one. Well, the problem with North Korea is that it's a succession anyway. So it was his father before him and his father before him. So as long as they keep having kids, you have the same problem of immortality, right? So that and then furthermore, generally, a lot of dictators do not die of natural causes. So that's another sort of mitigating factor. And then, even if it were the case that immortality would confer a longer reign for dictators, which are increasingly few in the world. I mean, we're getting fewer and fewer dictators over time. So it may be a self resolving problem eventually. Even if that were the case, then is that enough of a reason to justify the cessation of medical progress? So let's take another example. Suppose, grandmother gets to a certain age, 100 years. Do you decide to say, well, grandmother's gotten to this age, let's stop advancing medical science and extending her healthy lifespan, because, well, death gives meaning to life after all. Or, it's bad for the pension system if she lives too long. This kind of thing. Like, you would never pull the plug on somebody for these like social reasons, right? You would always enable them to live longer and prefer for them to be healthier. So there's no reason to attempt to stall medical progress just for the purpose of preventing immortal dictators or for saving the pension system or whatever. We have better solutions to all of those anyway. So for the dictators, all right, let's find a way of making it less likely for dictatorships to occur and persist. Or for the pension system, okay, if people are living longer, healthier lives and they're cognitively productive, let's delay the retirement age. Or maybe what I think is more likely than that, because it's politically not very popular, there will be such an immense economic dividend to curing age related diseases and extending healthy lifespan, that all of these questions about economic scarcity will be minimized. It's almost as though you had a new energy source. Like, say we were 100% nuclear and energy was too cheap to meter, we would not need to work until 65, right? It would be like Keynes predicted, John Maynard Keynes, the economist, predicted in the early 20th century that, humans would be working very little, part-time, 1 or 2 days a week by the year 2000 or whatever he predicted. Didn't work out that way probably because of waste by governments or whatever, or people just wanted to buy more stuff rather than have more leisure time. That's what Noam Chomsky thinks. Anyway, so long story short, there's something called the longevity dividend. And it's been calculated by a series of demographers that the economic benefit that you get from delaying aging and extending healthy lifespan, even by like 10 years, is in the many trillions of dollars. And so the economic benefit from that would far outweigh any kind of cost that you can imagine, say, the pension system for people living longer or whatever. And then the final point on this is if we fail in the longbio mission, if we fail to massively improve the provision of medical care, the medical systems, the current trajectory, the base case scenario that we are on now is dystopian because we have a global demographic aging crisis called the silver tsunami. And basically, the population is aging and we're having fewer kids. And when you have fewer children, there are fewer people to funnel into the Ponzi scheme, pyramid scheme of our current economic system, which relies on more people coming in to pay for taxes and take care of the old. And so all of these governments, including Italy and America, are facing these demographic challenges to Social Security and Medicare, government payments for pensions and health insurance. And so if we do not radically improve the quality of our healthcare systems, we are in a lot of trouble. And we're going to have, every other building in downtown or in your town is going to be an Alzheimer's care clinic at the extreme case here. That is the trajectory that we're currently on. And so we should treat the global demographic aging crisis as silver tsunami. We should treat it like the greatest threat to US national security or global national security. It's not wars, it's not terrorists that are the threat. It's always been in the last century, it's been aging and age-related disease that has been the threat. So we really need to prioritize that. And some of my friends, Nathan Chang and Adam Gries, have started a movement, a political religious movement, we joke, called Vitalism. Yeah, you'll hear more about this soon.
I'm intrigued now.
Yeah, yeah,
I wanna know more.
for sure. Yeah. So come to our conference. We're going to do a conference in Rhode Island in, I think, August, September. You can go on the website, vitalism.io. It was announced at Zuzalo. It's been in the works for a long time. My colleague and friend, Adam Gries, who lives in Puerto Rico, not too far from where I live, he has been, seeking to do this for a while. And so long story short, what is the Vitalism movement? It is a new cult that you should totally join. And basically, we believe that the ultimate good is health and life. There's a view that if death and disease are bad, then life and longevity are good, or the reverse. If life is good, death is bad, and disease is bad. I think we can all agree that disease is one of the things that causes the most suffering in the world. And so we need to memify this movement, and we need to gain political influence. And so this can be done by creating a sort of almost like religious or political movement, kind of like climate change did. Everyone got really millenarian and really like worried about climate change. And yeah, it's a problem, but it's the kind of thing that's not 100% guaranteed to kill all of us and cause like 10 or 20 years of suffering, right? Whereas aging, that's 100% guaranteed, no exceptions. And so no soup for you. So basically, if you know that reference. So anyway, we're going to do this conference, and it's based on the two case studies, the Zionist movement and the Mormon movement. And so Adam Gries, he himself is Ashkenazi Jewish, and he is sort of reflecting the Zionist movement and, believe whatever you do about the current political situation in Israel-Palestine, the Zionist movement was successful by its own metrics. So there was a gentleman, Theodor Herzl, who wrote an important book about Zionism. He had a congress in Basel, Switzerland. And so it was kind of an early example of the network state. You had this diaspora of Jews globally, and they came up with a plan to materialize in a certain place around a certain aligned mission, and they achieved it. And today, Israel, for its faults, is one of the most technologically advanced, economically advanced countries in the world. And so that's one example. Another example is the Mormon movement. So the Mormons originally began not in Utah, but in another state like Indiana or Ohio or something like that. Yeah, and they were persecuted by the locals. And so they had to flee. And so they moved to the wilderness in Utah. According to the Mormons, Jesus Christ was spoken to by some angel, and it was these tablets were buried in the United States, and it's a very complex story. But alas, the Mormons succeeded by every measure in making Utah a kick-ass state. Utah is, pretty high income. They pool their capital. They're well educated. They have achieved a lot. The sort of Mormon project, and so those are both kind of fringe things, and you can't really easily join them unless you're really weird if you're going to, convert to these religions. But we think we will have a lot higher success rate convincing people that if death is bad and disease is bad, then life and health is good. And what better thing to commit your life to than investing in biomedical science, technological progress to make ourselves healthy and live longer? And so that's the basic premise. And then final point on this, because I know in that biology style I tend to monologue, so hopefully I haven't lost too many people. I often say, this may not be original to me, but there's a religion-shaped hole in the human psyche. So basically, there have been studies of people who are like really zealous about certain non-religious things like Disney or Apple products or keto diet or whatever it is. And for some of these people, there's been the experiment where you put them in an MRI machine, a brain scanner, and the part of the brain that lights up when Christians see a picture of Jesus or what have you, religious people see an idol relic, the same part of the brain lights up when people see whatever it is that they're really super keen on. And so in the modern world, the secular world, we're missing those movements that really confer purpose and meaning to life. So I wouldn't say death gives meaning to life, but we do need something meaningful that is greater than ourselves, missions. And so my mission has been and will always be longevity biotech. I have some side quests too, but really longevity biotech is it for me. And that's the only kind of religious sort of all consuming thing that I need. So we're thinking of setting up a contingency in Rhode Island. So then we can make Rhode Island the absolute hub, the longevity hub of America. We're looking at Zug, Switzerland, other Swiss cantons, obviously Montenegro, where there's a new friendly government, and Vitalik from Ethereum is working on that. We're also interested in meeting with a couple of Latin American governments this winter. So stay tuned. Vitalism movement, definitely check out the website, vitalism.io. And the white paper is on the website too.
How do you think society needs to change to accommodate a population that doesn't age anymore? Right? You spoke about it a bit, but we need to have I think conversations, right? And I think like these vitalist movements goes in that direction, but it looks like technology, and I have this feeling also with AI, right? So technologies come first. We don't have any sort of conversation around the topic, right? And then it's like, oh, here we go. This is, the state of technology. These are already the impact that you can feel on society. Deal with it, right? So I wonder if there is a way in which we can have those type of conversation before, we get there with the technology. Because like my feeling is we're gonna have a population that doesn't age, but it's unproductive on the other side because we have advancements in other fields such as AI, and a lot of the jobs that we currently do are gonna be redundant, right? And if you look even farther ahead, so for now, like the most job at risk, I will say, are like white collars. But if you look, way ahead with robotics, probably also blue collars job. So what I envision when you talk about it, I envision sort of the Greek gods, basically, where you have like this population that doesn't age. The clock is always still, and they are largely unproductive. You know, and they ruin the earth and cause mischief and get lost in hedonism, which might not be bad, but I think we need to have those type of conversation way before we get there. That's my
Mm.
feeling.
Yeah, agreed. And thankfully, it's not a new conversation. I mean, since the king of Sumeria, Gilgamesh, the Epic of Gilgamesh, I don't know how many thousands of years ago, he was questing for immortal life, and so there has been a long canon of literature and thought around longevity. And so, if the worst outcome is that we become like Greek gods, we become like gods, and we have a lot of free time to engage in mischief and hedonism, I think that's a good problem to have. The main thing is just mitigating the problem that we now face, which is we are really in for a lot of trouble with the demographic aging crisis. So I think that's objective number one. And so, okay, what other problems might we have if people live a lot longer? Well, let's consider some of the upsides first. I mean, so one example I give is, what if the great geniuses, say Tesla or Einstein, had another couple centuries to do their thing without losing cognitive function? So knowledge is cumulative, right? So the more time you have to learn more and more of a subject, the more it builds upon itself. And so when you stop the clock at a certain age, you really have lost a lot. And then you have to wait for another human sometime in the future to go pick up where you left off, which is quite inefficient. So you were going to say something?
Yeah, because like I have actually the counter argument for that. I'm curious
Oh,
to know
yeah.
your opinion because like this is true, but it's also true, and you see it like in organization that, and I'm not sure that this is a byproduct of age or like of aging, not age, but aging. I mean, older people in general, not everyone, tend to have more fixed opinions and beliefs. They tend to become slowly more um,
Yeah, I've heard this. Yeah,
unflexible.
yeah.
You
Elon
know what I
Musk
mean?
made this argument too. Yeah, Elon Musk made this argument that,
I didn't know, but like, great.
yeah, well, you and Elon thinking alike. So basically, uh, there is this theory from people like Max Planck, the physicist, that said science progresses one funeral at a time.
Yes.
Basically, you need to clear out the old to make room for the new ideas. And
But new ideas come from new people. And like, if you have a population that is usually stationary and it's always the same and always the same people, do you get that anymore?
yeah, well, we can probably find ways to mitigate that don't involve people dying prematurely. I mean, you could take the extreme argument too. Like if you take it to its logical conclusion, it's like, all right, by the time someone hits 50, you're not having any good new ideas, so we should probably just kill you and take you out of the gene pool, take you out of power, because we need fresh ideas. And to some extent, I'm sympathetic to a less violent variant of that, which is what my friend Michael Gibson at 1517 Fund does. And I did a podcast interview with him recently as well, which you should all check out. He's awesome. He wrote this book called Paper Belt on Fire. There was actually, the term came from biology, as all good things do come from our god emperor biology. And basically, he argues that historically young people actually make significant contributions. And it's just evolution, right? Like your cognitive function peaks before age 30, usually around age 20, and your physical performance, all of this, like most chess and mathematician are at the top of their game, before age 30. By then you're washed up. So there's definitely something to be said for prioritizing young people and not like ruining young people through the system of education we have that like crushes their souls and makes them disinterested in intellectualism and so on. That somehow the education system like manages to make science boring for most people, even though it's absolutely fascinating if you are taught the wonders of it. So yeah, I'm sympathetic to the idea that we should be giving more leeway, more credit to young people. And this whole system we have of like waiting until someone spent like 30, 40, 50 years of their career to like prove themselves and prove their credentials before they can do a startup or do something cool. Obviously, I mean, I think that's falling out of fashion, as we've seen in the Bay Area, prioritizing young people and dropouts who have the energy and the drive and so on. So, okay, but yeah, there may be, so, okay, maybe we can frame the argument this way, which is we can you'll be charitable and agree that extending healthy lifespan is definitely a good thing, but there could be some side effects. So it's not that we should not pursue longevity. It's just that we should think of ways of mitigating some of the potential side effects. And I agree, like one side effect is compound interest. So Albert Einstein said the most powerful force in the universe is compound interest. And like we've seen with people like Warren Buffett, if you start compounding money early, returns early, you'll accumulate a huge amount of resource. And we already have a situation where it's a gerontocracy. We have old politicians, we have older people who allocate most of the capital in the world. And so between the two of them, 90% of what actually happens in the world is determined by people over age 50, let's say. And so that would just become more extreme. The question is, how do we mitigate against that? And might it actually, on balance, be a good thing, right? You do accumulate wisdom with age. And so I'm not too terrified about that outcome, but it would basically increase the returns to longevity in terms of compounding if your investments are doing well. So
What is going to be the effect on natality? Yeah, what is going to be the effect on you know basically building families and making babies?
sure.
Uh,
Yeah. Yeah. I mean, we already see, even with the modest longevity gains we've had, which is about 1/4 of a year per year for the last couple of decades, we've got 1/4 of year longevity gains. Those will probably plateau in the near future if they haven't already in your country, in whichever country you're in. And so, because of that, or more because of other factors like women's education, contraception, et cetera, people are having fewer kids. That's part of the demographic aging crisis. It's that we're having fewer kids while living longer. So I don't know if we will have fewer kids. I mean, we may have more kids actually, because if you're in better health, your fertility rate goes up, you're happier, you have a longer life. You may have you may be able to have children for an extra century, right? So you actually may have more kids, just not as frequently. But yeah, I mean, the way things are currently going, UN predicts US or the global population is going to peak around 2050 or 2060, and then sort of slowly decline after that. So I don't think that's a big problem as long as we have robots and AI that can do a lot of the jobs and like take care of the humans that do exist. It'll be more a matter of quality over quantity. So we will be doing germline embryo selection, for example, to make people way smarter or way healthier or way happier, etc. So it's just going to be more of a quality versus quantity sort of approach. And that'll be good for the people that are alive because heretofore governments, particularly governments with large populations like China, for example, don't place a very high value on individuals. And so when you have it's economics, supply and demand. When you have an oversupply of something, including people, you just don't value it as much. Or like if you've ever lived in a big city versus a small town, small town people are nice. They want to get to know you. They have time for you. They value people because they're not everywhere. But in New York, like people are like rats, like they're just too many. And so, New Yorkers are famously rude and in a rush. And so I actually think it'll be good in 1 or 2 centuries when we actually have fewer people on Earth, or maybe roughly the same as we have now. But all of those people will be better taken care of and more valued than they are today.
yeah, I mean, when I hear you talking, I'm like split in the middle. On the one side, like I see this amazing utopic kind of future, of abundance of a population that lives longer and healthy. And on the other side, I'm kind of envisioning a brave new world of Huxley, especially when we were talking about gene selection and you know, deciding what attributes you should have in labs, before you're born.
Agreed. Yeah, we're going to choose between a future that's either Orwellian 1984,
Yeah.
with authoritarian governments and central bank digital currencies and all of that, or maybe a nice version of Huxley's Brave New World. And, who's opposed to less disease, less infirmity, less ignorance? You know, it's often said that I think it was Craig Venter who said this. Steve Jobs of Apple said something similar, which is the 21st century will be the century of biology. Last century was a century of physics and chemistry. And now that we're able to increasingly precision engineer biology, it's going to be a revolution and it will be the most impactful, I think. So, yeah, the embryo selection aspect of Brave New World, I think that was one of the utopian aspects of it.
Yeah. I mean, different ways to see it. It depends on how you engineer it, right? If you engineer it to eradicate certain type of genes that conduct disease, for sure. If you engineer it to eradicate um, genes and make everyone look alike and erase a certain type of race, then we get into the real dystopia. But um, s-
Yeah, I mean, I think the key question is who is doing it. So
exactly.
if the government is forcing you to, I don't know, do X, that's very risky, and that's where we ran into problems in the past. But if you are electing with maybe your partner to give the best life that you can for your child, I don't think there's anything wrong with that. I mean, we already do sexual selection when we choose a partner, their genetics. We already do SAT prep to make kids score better on tests of IQ. IQ itself is one of the most important predictors of future life outcomes. It's one of the most accurately measured psychometric properties in all of psychology. And so, what would someone do for an extra 10 or 20 IQ points? It's definitely worth considering. So yeah, I'm not at all opposed to people, tweaking biology just like people do cosmetic procedures today, or they, invest a lot of time and energy in improving their health. Why not just make it easy and do it at the genetic level? Yeah, but I'm sort of more of a libertarian myself, and I shudder to think, what might happen if governments are forcing people to engineer their children in any particular way. So I think the government should definitely stay out of it.
Sebastian, I really want to thank you for this very wide ranging conversation. Uh, it has been an absolute pleasure having you on the show, and I love you to have you back at some point in the future when the research as well progress, and continue this conversation. Really, thank you.
Yeah, thank you. It's been fun. And I enjoy your podcast. So I'll look forward to listening more.
Okay, and for listener, we'll see you on the next episode. Bye. That's all from today's episode. Thank you so much for watching or listening. If you find this episode valuable, you can subscribe to our YouTube channel or to the Polyweb podcast on Spotify, Apple, or your favorite podcast app. It will be fantastic if you could leave us a rating, a review, or a comment, as this really helps other listeners find the show. All the resources mentioned in this episode will be linked in the description and in the show notes. See you on the next episode. And if you cannot wait until next week, you can watch this episode right here that relates to some of the things that we talk about in this episode. Bye.